Let's go over our first two axioms. I'm actually going to combine a few axioms into others and gonna number them a little bit differently than I should be. I think this makes it a little bit easier. So, first axiom, I'm just going to call it Axiom Zero. And this one's going to be a combination of a few axioms. So the first statement in Axiom Zero is every line contains at least 2 points. So something about this first statement, we don't know how many points a line contains. Every line might contain at least 700 points, but we know that number is at least 2. It turns out, well, we don't need an axiom to tell us how many it contains. In the future, we'll prove that every line contains an infinite amount of points, but that'll be a proof, not an axiom. So the second statement that we're going to include in this axiom is that there are at least 3 non-collinear points. I'm going to abbreviate points as PTS because that's a word I'll be writing a lot. And then there is a final statement in this axiom. It is a plane has 3 non-collinear points. So a plane has 3, well, actually, I'm sorry, that should be, a plane has, yeah, at least 3. At least 3 non-collinear points. So if you'll notice, this far, we don't actually know what a line, a point, or a plane are. You probably know that just from previous experience with geometry. But so far, in what we are building, there is no definition given of any of them. I'm not actually going to give a formal definition of them, because definitions have to be built on previous definitions, and I can't give a definition of those. The normal one is, point is that which has no width or breadth, and then a line is that which has breadth but no width. But those can be kind of tricky to define, so I'm actually just going to assume you're familiar with the notions of those and what they are. So axiom number 1, this axiom luckily has a name. It's called the point line incidence axiom. A lot of times I'll just refer to this as point line incidence. So point line incidence says that if you're given any 2 points, there's exactly 1 point containing them. So given any 2 points, there is exactly 1 line containing them. Let's talk about both of these for a little bit. For Axiom Zero, Axiom Zero pretty much says that a plane does not equal a line, because every line has at least 2 points. And a plane has at least 3 non-collinear points. So qualifications for those, although those could overlap, the qualifications are such that they have to be different things. Otherwise, we would have had a different axiom. Because we want to have as weak of axiom as possible. And the weakest axiom we could have for a plane is that it has 3 non-collinear points. If a plane was a line, we could say that every plane has at least 2 points. Our second one, point line incidence. This is saying that, so given any 2 points, let's say we have these points here and here, it says that there is only one line containing those. That would be this line right here. So it's saying that we can't have some kind of other line, like I'll do the wrong line in red. It's saying that we can't have some other line like this that contains them. That line does not exist.